All right, little application problem here is we've been working with quadratics, solving quadratics. Maximize the area of a rectangular corral built from 100 feet of fencing. So let's just picture that. Let me draw a little corral. So we know that we've got 100 feet of fencing is all that we have. We want to maximize this area. So this side plus this side plus this side plus this side has to add up to 100. So let's just throw some labels in. What if I did like width, length, you could use X and Y's, I guess you could use whatever you wanted. So let's see what we know. Well, 2L plus 2W, right? 2 times the length plus 2 times the width has to add up to 100. Let me simplify that. What if I divided 2 through that? So L plus W, length plus width, has to add up to 50. Okay. Then let's maybe just make it in terms of one variable to help us out. What if I subtract that 50 over, or I'm sorry, let's subtract one of these over. How about, let's do L. So what if I subtract L over? So the width is 50 minus the length. So that relationship has to be true. Well, why did we just do that? Let's think about it. Well, what do we know? What's the area of a rectangle or a shape like this? Well, it's length times width times length, right? So it's LW. That's too many variables for us. That's why I simplified this in terms of one variable. So let's substitute. So L times 50 minus L. So my area is 50L minus L squared. Well, that's the equation of a quadratic, isn't it? So we've got different ways now. We basically want the maximum. Let me just rewrite this. Minus L squared plus 50L. Kind of put it in the order. Usually we've got our squared part first, right, if we put it in descending order. So we've got a quadratic. It's got a minus out front. So it's pointed like that. Well, there's the maximum value. Sorry, that's off the screen there. That's the maximum value. They basically want us to figure out, well, what's the vertex of this thing? What's the maximum value? Now, there's different ways that we can do that. One way is you could go graph this on your calculator and play with it until you find the maximum value. That's not too bad. Another way I'm going to go ahead and just do here is complete the square on it. Let's put this equation into standard form because the vertex is what we want. It's right there. So if I knew the vertex, I've answered the question. Let's go ahead and do that. So if I put this in standard form, we come over here a little bit. And let's factor that negative sign out. So I've got negative, then that would give me L squared minus 50L plus something, right? Now, no other number out here to worry about. Well, what goes in the box here? So half of 50, that's 25, squared, well, that's 625. So we're going to add 625. Now, what goes out here, remember? So normally I do the opposite, but this, be careful, we have a minus in front. So this actually minus 625 is what I just added. So I'm going to add a positive 625 out front. Now if I rewrite this, so L minus 25 squared plus 625. So here's my equation, but notice it's in standard form now. Well, what's the vertex? So my vertex is 25 and 625 is the y value that goes with that. So maximize the area. So the maximum area is 625. That would be that y value right here. And how do you get that? By having your length and width actually be 25 feet. So if you did square actually corral, not a rectangular corral, 25 by 25, that would maximize things for you. Again, there's other ways that we could do this as well. But that's one kind of building on what we've been working on this lesson that I thought would be appropriate.